Well, good morning, good afternoon, or good evening, wherever you may be joining us from. My name is James Darcy, and I have the pleasure to be your Airbus host today. Almost 18 months ago, Airbus formally launched its zero emissions journey with the unveiling of our ZEROe initiative. And we've gathered today to mark another major milestone in that journey. And to do so, I'm joined by a number of distinguished guests here in the Airbus Experience Center in Washington, D.C. To my left is Jeff Niddle, Airbus America's chairman and CEO. To his left, Gaël Mehust, CFM president and chief executive officer. And finally, we have Mohammed Ali, vice president and general manager of GE's aviation engineering division. Also joining us from Toulouse, where Airbus headquarters are located, I would like to present Sabine Klauke, Airbus chief technical officer. And with Sabine is Michel Brioude, Safran Aircraft Engine chief technical officer. And I'll let them explain exactly where they are located in just a few minutes. After we hear from our guests today, which should take about 30 minutes, we will then answer questions from our members of the media who are joining us virtually. For those journalists, we ask that you submit your questions using the Q&A button to the right of your screen, and that you begin your questions with your name and your media outlet. Should you have any technical issues and need assistance from the moderator, you can post that request using the chat function. So now, without further ado, let me turn things over to Jeff Niddle to explain why we've all gathered here today. Jeff?
Thanks, Jamie. It's a pleasure to be with you all today. And I don't think it's an exaggeration to say that today is truly a historic day for aviation. In September 2020, you may remember, we unveiled our ZEROe concept aircraft. And we explained at that time that our ambition was to market a carbon neutral aircraft by 2035. In order to reach that goal, we have to design and develop propulsion technologies based on hydrogen. And we have to test them, first on the ground and then in the air, before a final technology solution is selected for the ZEROe aircraft program. So today, I'm not only proud, but I'm truly excited to announce that Airbus has signed a partnership with GE Aviation and Safran through their joint venture, CFM International, to collaborate on and develop a flight test demonstrator based on hydrogen. The ultimate objective of this project and this partnership is to flight test a direct combustion engine fueled by hydrogen in preparation for entry into service of a zero emission aircraft by 2035. The aircraft used for the flight demonstrator will be an Airbus A380, equipped with liquid hydrogen tanks that will supply the engine, which is located along the rear fuselage of the aircraft. Now let's take a look at this extraordinary test platform. As you might imagine, we've worked hard to get to this point, and I'll let Sabine elaborate on the technologies we've already developed. Today's announcement, however, showcases how collaborating with our industry partners has been fundamental at every step of our journey. In September 2020, we launched discussions with suppliers worldwide. Just a few weeks ago in Alabama, we held a sustainability summit for suppliers to ensure that we are ready to take on our common challenges. We've created a joint venture and sealed partnerships with airlines such as SAS, EasyJet, Air New Zealand, and Korean Air, and many others soon to come. We've also engaged with airports around the world such as Vinci Airport, Airport de Paris, Milan Airport, Incheon in Seoul, and Changi in Singapore as key infrastructure participants in this new environmentally friendly ecosystem. Finally, we've partnered with energy providers in our journey to decarbonize, in particular, Air Liquide, Linde, and Plug Power, who's right here in the US. Today's very special partnership with CFM is the latest example of what our industry can accomplish when we all work together.
All right, thanks, Jeff. And that's the perfect segue for us to talk about CFM International's role in the new partnership. Gael?
Thank you very much, James. Good morning. I'm Gael Meust, and it's an honor and a privilege to be here today representing CFM International as its president and CEO to take part in the launch of this historic partnership to successfully test a hydrogen propulsion system around the middle of this decade. Along with Airbus, CFM and its parent companies, GE and Safran Aircraft Engines, are deeply committed to helping the industry achieve the net zero carbon emissions goals that we collectively set for ourselves through the Air Transport Action Group declaration last October. To achieve these goals by 2050, the industry has to take action now, and we are. Even in the midst of the most challenging time in aviation history, we launched an advanced technology development program, the CFM RISE, which stands for Revolutionary Innovation for Sustainable Engines. This was in June of 2021, in order to demonstrate a range of new disruptive technologies for future engines. As the name implies, sustainability is at the heart of this program. The RISE program embodies CFM's mission to push the limits of innovation, to develop, to demonstrate, and to bring to the market breakthrough technologies that will advance the industry while helping to protect the planet. Obviously, achieving sustainable aviation growth requires a holistic industry-wide approach. From the CFM perspective, we certainly support the broader use of sustainable aviation fuels, something the industry can do today to have a huge impact on its carbon footprint. And of course, all of this in addition to building ever more fuel-efficient engines. A key objective of the CFM RISE program is to ensure that any engine we introduce in the future will be compatible with alternative fuels, such as 100% SAF. But the goal of this industry is not just to lower the carbon footprint. It is net zero carbon emissions. To achieve that, we need to explore all the technology paths at our disposal, and hydrogen propulsion brings great promise. It is the true zero carbon emissions solution. Recognizing that potential, CFM set hydrogen combustion capability as one of the fundamental technologies we are developing and maturing as part of the RISE program. Fortunately, hydrogen isn't anything new to this team. Both Safran and GE have millions of hours of combined experience with hydrogen fuels. Safran through powering space vehicles and rockets, and GE from running hydrogen blends in aero-derivative engines. As Mohamed and Michel will explain in a few minutes, we still have some work to do, obviously, but we don't see any unsurmountable technical challenges. Bringing together all of this collective experience, along with a shared commitment to make zero carbon emissions a reality, we really have the dream team in place to successfully demonstrate a hydrogen propulsion system in this decade.
All right, thanks very much, Gael. Now it's time to go to Toulouse. And Sabina, let's start with you to explain, first of all, the rather unusual surroundings you find yourself in today.
Thank you, Jamie. And hello, everybody. I'm so excited to be here in the Toulouse A380 Lagardère site, together with Michel Brioude. And literally, we are in our hydrogen demonstrator. And this is really a huge step towards sustainable aviation that we are doing with launching the demonstrator today. We are completely for making everything ready for being launch ready or being in the market with the first commercial aircraft zero emission by 2035. So today we are standing in the MSN-1 A380. So it's the first ever built A380, and it has actually served for the certification and testing during the A380 industrialization. And I myself have spent a lot of hours in these airplanes. So it's all the most more exciting to be back here today. We also use the A380 MSN-1 for the flight test of the engines of A350. So the aircraft itself has also already a big track record. And if you look in the cabin, it's not looking like a usual customer aircraft. It is because it's a test aircraft. And so let's have a look at what we have to do in order to make it our hydrogen demonstrator. As we've seen in the little film just behind us outside, we will install a stub, a support to put a gas turbine for hydrogen combustion. And secondly, just below us here in the main deck, we will have 4 hydrogen tanks which will be installed and which will be delivered from our zero emission development centers that we opened in Bremen, in Nantes and in Madrid last year. These tanks will be hermetically sealed with a hermetically sealed container so that everything will be safe. And as well, we will install the distribution system right to the engine in order to make it fly. Then here, so we just have an aircraft flying by, so that's good news. So actually, in order to do this flight test, from the flight test, we want to learn whatever we can learn from real operations during flight and on the ground. So it means that we need to capture data, a lot of data of the flights, and we will actually install a lot of sensors around the engine, the tanks and the distribution system, and they will have to be captured in the test center here on the aircraft, the data test center, and we might have a picture even of that. And this is where the flight test engineers will actually real-time operate the flight test on the ground or in the air. And we will also, via telemetry, send the data back to the ground, where we have our flight test engineers actually managing the overall flight and also analyzing the data. So what else does it need to make this hydrogen demonstrator a real demonstrator? We will also modify the cockpit. And here we can just see the data center on the aircraft. So the cockpit modifications will actually install a throttle so that the pilots will be able to manage the power that is actually going to the hydrogen engine. And they will also have a display specifically to oversee the main KPIs of the whole system. So you can see that this hydrogen demonstrator will need a lot of interaction of the test pilots, the test engineers, the flight engineers and the ground crews, and all the partners which are working with this. So I really want to thank everybody already today for their motivation, their engagement, and in order to make it happen. And I also want to thank everybody of you present with us today to be part of this journey, this immense journey and this exciting journey towards zero emission aviation and sustainable aviation in the future. Thank you.
All right. Thank you very much, Sabina. And now we're going to bring the conversation back here to Washington. Mohammed, I think it's time for our science lesson. Tell us a little bit more about the hydrogen combustion engine itself and some of the unique challenges associated with it.
James, what a great introduction. Good morning, good afternoon, good evening, everybody. Thank you for having me. My name is Mohammed Ali, and I have the honor and privilege of leading the engineering team at GE Aviation, which is one of the two parent companies of CFM International, along with Safran Aircraft Engines. I'm incredibly proud to be standing here with Airbus, representing CFM to develop these technology solutions for the future of flight. Sustainability is our North Star. And last summer, we announced the CFM RISE Technology Demonstration Program, RISE standing for Revolutionary Innovation for Sustainable Engines. GE also recently won with NASA a program to develop megawatt-plus hybrid electric technology, leading to a full flight demonstration. And a few months ago, I personally and some of my colleagues, we were part of the world's first passenger flight using 100% sustainable aviation fuel. Today, we are participating in this exciting hydrogen demonstration announcement. This is another big step forward toward our commitment to a more sustainable aviation industry. Hydrogen is both exciting and challenging. But we are not starting from vacuum here. GE has more than 8 million hours of experience with hydrogen combustion already today with land-based gas turbines. We are ready to take that experience to the next level and literally fly with it. Let's now go behind the scenes a little bit and inside an aircraft engine to understand what hydrogen means for the engine and the propulsion system. To distribute the fuel from the storage tanks to the engine combustor, it will require development of a new cryogenic fuel delivery system. Remember, the hydrogen starts at cryogenic in the tank. Before the liquid hydrogen can enter the engine's combustion chamber, we will need to convert it into gas to be burned cleanly inside the combustor. Michelle, my colleague at Safran, will explain this in more details. And unlike jet fuel, hydrogen is actually then injected into the combustor as gas, making its mixing with air to actually be easier. But hydrogen burns at much higher temperature than jet fuel does today. We will build on CFM's legacy of innovation in advanced materials, coatings, cooling technology, develop combustor and turbine parts that can withstand that temperature and achieve same or better durability than what we have today. Now, burning hotter also means more susceptibility to other forms of emissions like nitrogen oxide. This is when we will leverage all of our experience of how to substantially minimize that nitrogen oxide formation. Hydrogen also burns faster than jet fuel, like 10 times faster, requiring new designs and technologies to control the flame and make it stable, which is where our legacy of making revolutionary steps in combustion technology will rise to that challenge. As our next steps, we will modify an existing GE Passport engine for the purposes of this program, adjusting its fuel distribution system, combustor, and controls to work with hydrogen. We will fly the modified engine to learn the art of the possible and to prove out the technologies. What we learn from this program will inform us about potential future engine developments. Is hydrogen harder? Yes. Is it doable? Absolutely. And we are building on tremendous experience here. And I'm actually very encouraged by the inventions we have already made to address those challenges. We are not a team that shy away from hard challenges. We believe we can make the future of flight affordable and more sustainable, all together with safety as the number one above all. This is actually what motivates us. And with that, I turn it back to you, Jeff.
All right. Well, thank you, Mohammed. And first of all, let me just acknowledge we seem to be having a little bit of a technical issue with our broadcast from Washington, D.C. You're getting our audio, hopefully, but not our video yet. But in the best traditions of live theater, we're going to keep on with the show. It's clear that this endeavor involves a wide range of technological, ecological, even human challenges. And to speak more about some of those, we're going to go back to Toulouse to hear from Michel Brioude, Safran Aircraft Engine Chief Technical Officer. Michel, could you please tell us a bit more about everything that's going to be tested with this demonstrator?
Thank you, James. So I'm very proud to be in this beautiful A330 with Sabine, and it's a good opportunity to talk this hydrogen and joining this ambitious project. So let me talk about the hydrogen challenges. On the technical side, as you know, the new technology is required by the hydrogen propulsion. Liquid hydrogen will be stored into the fuel tank. It will be a cryogenic new technology, cryogenic fuel tank and cryogenic fuel system. And after that, to deliver the hydrogen into the engine, we will have to develop a new fuel pump, cryogenic fuel pump. We'll have to develop new piping, new seals, everything with new materials as mentioned by Mohammed. On the other side, hydrogen is stored into the tank at minus 250 degrees C, which is 420 degrees Fahrenheit. So it's very a step forward in terms of technology. Now, Mohammed talked about that we need to convert liquid hydrogen into gas. For that, we will have a very new heat exchanger for that. We'll have the highest differential temperature and pressure, very different to what we are using now in this aviation industry. On the other side, we're using Jet A now for some function of the engine. So no more Jet A, we need to bring invention and new system for that. Another point which is very important is altitude relight. Altitude relight is always a key point on our side, so definitely we'll have to address that. So many technical issues, but I can tell you that we are committed and we are confident that we will address them. On the other side, during the flight test program we'll do with this aircraft, okay, what we want to characterize is the condensation trails produced by the engine in different atmospheric conditions. Okay. As you know, and we talk about that, combustion H2 do not produce CO2, but it produces 3 times more emission of water. So that kind of condensation trails may be a contributor to the greenhouse effect. So that's why we need to measure that. Today, we don't know how long it lasts into the atmosphere, but we need to do the test, capture the phenomenon, characterize the phenomenon, collect the data to be able to provide a demonstrated and substantiation response to the climate change. On the other hand, beyond the technical things, there are human also challenges. As you know, well, Gael talked about and Mohammed talked about sustainability. On the CFM side, over the past 40 years, we have reduced the fuel consumption of our product by 40%, which means reduce CO2 by 40%. And also, we have reduced NOx particles, things like that. What we are looking at now is working with the team and building solutions to address that. So the way we are looking, it's an ultra-efficient engine, like the open fan, which will be able to use SAF, but also hydrogen. And all our teams are fully committed for that. For the next 2 decades, it will be their top priority. And especially for the youngest engineers we have in our team, these challenges have an echo beyond their professional life. Now, if we look at the ecosystem, we can count on the support of the government. Okay? We need them to develop these new fuel industry, sustainable fuel industry. We need them also to develop and put in place the infrastructure to use those new fuels, including hydrogen. We also expect and need their support in funding the research for a more efficient propulsion system as well, new fuel. We know we can count on Europe Clean Aviation Initiative, and they will work closely with us to ensure that we have a successful transition to decarbonation. So H2 is a challenge as difficult as it's passionate, but necessary. Thank you. We can't hear you, James.
Personal note, part of this partnership for ZEROe. Our industry is an organization challenge on many fronts, including the increasing utilization of sustainable aviation fuel. In fact, every aircraft that Airbus delivers from our manufacturing facilities in Mobile, Alabama, are delivered with a SAF blend on board. It's our view that hydrogen propulsion is a fundamental part of the long-term solution, and we remain realistic about the challenges that such a transformation of aviation presents. We are committed to this new aviation future, and we fully embrace the opportunities and the challenges that lie ahead. Our confidence comes from the knowledge that at every step of the journey, we will be with successful and great partners like CFM, who will be at our side. At Airbus, we pioneer sustainable aerospace for a safe and united world. We invite everyone and welcome everyone to join us on this important journey.
Thanks very much, Jeff. We've got about half an hour now to answer questions. Let's go ahead and begin. And just a reminder, if you're continuing to post questions, please do give us your first question today. Looks like it's going to go to you, Sabina. That's from Gilles Bousquet from La Dépêche, who asks, what is the schedule to implement the hydrogen system on the A380? And would also like to know where and when the flight test.
Okay, the overall flight test plan is still under consolidation. We are actually starting to mature the initial, the technological bricks one by one, already with ground tests this year. We will then convert the aircraft, and we are planning to fly by end of 2026. So, but the overall flight test is still under consolidation. This is bringing us actually to technology choices by the end of the decade and preparing us for maturation into 2035, as we want to be in the market by then.
Thank you, Sabina. I've got one more for you from Richard Sherman with Air Insight. Why has the choice been made to put the engine in the position where it is on the A380, that upper position of the upper deck, versus putting it under the wings?
So actually the position is here to really well measure as well the atmosphere as well as the overall system. So we have a very, very good integration between the tanks, the system and the engine. And then, as Michel said, we also want to measure everything which is happening in the atmosphere, and this is why we chose exactly this location.
All right, thank you, Sabina. Richard has one more question, but this one actually, Mohammed, is for you. Richard is asking what the power output of the engine is, and whether this is an all-new core or is this based on the
as you know, GE Passport is in about the 20,000 pound plus class. It was intended for regional and business jet application. Business jet application. It's we certainly will multiply the combustion, as I spoke about. That's certainly a cost for. However, we intend to actually minimize these modifications that's core, so that we actually simplify the entire program. The core of Task 20 is quite similar to quite little similarities. We do that actually is one of the attractive parts of doing it with the G.
Thanks, Mohammed. Sabina, we're actually going to go back to you for the next question. So this one comes from Tim Beaver. Hi, Tim. He wants to know if you decided on a concept for the ZEROe aircraft body itself, and whether the fact that you're testing a conventional engine now means that we've moved away from blended wing.
So if I got the question right, it is about, do we only look at hydrogen combustion? Actually, this is one concept, one technical concept that we are looking at. We are also looking in all other types of technologies, like fuel cells, and we are maturing actually brick by brick, and we will then do the choices when the technology bricks themselves have matured, and we can do the choices by the end of the decade.
And actually, Sabina, if you don't mind, I'll try to clarify the question a little. I think he's also interested in understanding whether we've decided on the physical form factor of the ZEROe aircraft, whether we've moved away from the idea of that being.
Okay, thank you. Actually, the overall configuration of the aircraft will be decided exactly by then, by the end of the decade, when the technology bricks are clear, and when we are also deciding on what is happening in the market. And you know that we are looking at different configurations so far, between 100 and 200 pax, and also between 1,000 and 2,000 nautical miles. So we will do that definition and the choice of the actual configuration of the aircraft only in a couple of years from now. We have 3 to 4 that we are looking into depth, but they are also linked to the different technology choices, of course.
All right, thanks, Sabina. And one more for you. This one is from Graham Moore at Aviation Week. He wants to know whether this demonstration program is also going to look at issues like ground handling of the liquid hydrogen and surrounding infrastructure.
So it is about the ground handling, right? So overall, of course, we are looking into doing an aircraft, but we also put a lot of effort into cross-sectorial working together, as some of my colleagues have already said. We are building alliances, and Jeff named them. We have alliances as well with the different airports around the world. So we've already some with the airports of Paris, with Lyon, with Changi in Singapore, with Incheon in Seoul, and a couple of other ones, where we are exactly looking at this. How do the airports get prepared for the ground operations together with the different hydrogen providers, with the ground transportation themselves, with the production areas, and of course with the regulators and the different providers. So this is really key in this endeavor, that we are also playing cross-sectorial in order to prepare everything at the same time.
All right, thank you, Sabina. Let's talk a little bit about the hydrogen tanks themselves. So Jan Kuchenik from Aaron Cosmos wants to know whether the hydrogen tanks will be made of some form of composite. Who would like to field that one?
I think I have to take it again. Yep. Because already last year we actually opened different zero emission development centers. One in Madrid, another one in Bremen, and another one in Nantes. And they are actually looking at the different possibilities, or doing it with CFRP, with composite, or doing it with metal tanks. So everything is looked at in order to, again, mature the different technologies and do the right choices.
All right, Sabina, I hate to say it, but we might have one more for you here. This one is from Sebastian Steinke from Flugerview, and he wants to know what the structural modifications are that need to be made to the A380 airframe itself, in order to support this test engine?
Okay, so basically it's, I mean, first of all, you see that we have a lot of space. So that makes a lot of possibilities to install all the different elements that we need for the different systems. So what we will do in terms of structural modifications is the support that you've seen in order to install the engine. And then the rest is basically systems which will be installed, including the tanks, which will be in a container which is hermetically sealing them. So that's not exactly a structural modification of the aircraft, but of course there is a lot of groundwork that has to happen there. All the rest is basically systems installation.
And Charlotte Ryan has posed a question about the choice to use an A380 itself for a test aircraft. Why use an aircraft that's so large when all of our sort of ambitions towards ZEROe favor something more in a single aisle aircraft? Is it because you need the extra capacity for the hydrogen tanks?
First of all, in order to do the demonstrator, it's really as well about space. In an A380, we can easily install additional systems and tanks, and as well the hermetic sealed containers that we can do. And this is due to the space that we have on that aircraft. And as well, having an aircraft with 4 engines, giving the possibility to, in the back, install the additional engine is really giving the optimal for this testing and demonstration flights.
All right, thank you. So this might actually be a good question for you, Gael. This one comes from Le Figaro, who would like to know, can we be more specific about the kinds of investments that are being made in this engine, and also a little more precise on the number of flight hours that are anticipated for the test schedule?
Okay, so, well, it's going to be representing a significant investment, but it's going to be part of the normal Safran and GE responsibility of investing into research and technology for the future. So at this stage, we are not disclosing necessarily any numbers. And of course, we're also very interested by the interest that the European Union, for instance, is giving to hydrogen. The French government also expressed a strong interest in hydrogen propulsion. So we can also have hope there to receive some support. When it comes to the number of hours, I mean, we're still building the plan. We have obviously some idea, but we need to continue our discussions with Airbus and set it up completely before having a precise number.
All right, thank you. Sabina, Tom Boone from Simple Flying has asked why Airbus chose the A380 for ZEROe. I think you've clarified this is just a test aircraft. But he had an interesting follow-on, which is what will actually happen to this airframe once this test program is complete? Any insights?
We will keep that airframe for the time being for all kinds of different test flights, and we will determine at the time being what goes on. But this asset is actually a huge one in order to do all kinds of test flights, as well engine tests, as we've seen. So this will probably go on.
All right, thank you, Sabina. So this next question, I think, Jeff, I'm going to send your way. John Walton from Runway Girl Network wants to know, what are the biggest challenges that Airbus and CFM respectively expect to have to surmount in this project? So Jeff, perhaps you can start for Airbus, and Gael, you can speak to CFM.
Well, a couple basic points. Obviously, this has got to be a holistic solution, hence the partnership. Sabina and I both talked about the supply chain. We've talked about airports. We've talked about the airlines. I think the biggest challenge is working through the technological bricks, making sure that the entire ecosystem understands the opportunities that we're looking at, the challenges we're facing, and bringing the resources necessary to solve those problems together. And this is a step, a concrete step in that direction. So I would say that a holistic view of solving the issues with a vision for the future. And I think that is where we're aligned. sustainable aviation is the future, and hydrogen is a important step in that process, and maybe the ultimate step.
Gael?
And for us, I would say the challenge is really technical, of course. We are going to start with an engine that runs with jet fuel. And the goal is to have this engine be operated using hydrogen. And Mohamed and Michel have explained a lot already about the challenges that are related to that, but transforming the liquid hydrogen into a gas that can be burned into a new design combustion chamber with a redesigned fuel distribution system, for instance, and all the controls of the engine to accommodate all that. So there's a lot of work to be done, but it doesn't seem to be unsurmountable. Of course, I'm not doing the job; he's doing the job, so it's easy for me to say, you know. But I would say, you know, we see the path, the technological path to achieve that, and with effort and hard work, we should be able to make it.
All right, thanks, Gael.
If I may add to that, thanks, Gael. They are hard, but that's what we are all about. And we're not doing them just because they are hard. I mean, that's not exactly right. We're doing them because we actually believe we can make the future flight, we can invent the future flight, and it's safe, and it's affordable, and it is sustainable. And that altogether can actually be done. And it requires inventions. Great. That's why we are here to do that.
All right, thanks, Mohamed. That actually segues nicely into the next question, which is, what extent do you need to be working with regulators as you are developing these technologies, such as the FAA, EASA? Perhaps you can speak to the FAA US side, and then Michel, maybe we'll ask you to comment on
very much
regulators in Europe.
Absolutely, very much so. Creating a new system that is a new energy system that we will fly off it as well requires, as Jeff said, partnerships. And starts with companies across the industry, our customers, the regulators, governments, and NGOs, non-governmental organizations. It requires all of us to actually partner to achieve that sustainable goal, and working with the regulators across the board, actually, in this program and in every single program we're doing from day one. Quite important for us, whether it's FAA or EASA or global regulators as well. So clearly, this is a key part of this development program. We build together with them a regulatory framework that will meet the safety requirements that the public is expecting from us.
And Michel, perhaps you could expand on that in the context of European regulators, and to what extent you see the certification of hydrogen propulsion as a challenge.
Okay. Well, today we are at day one of this wonderful Airbus CFM project, but we have already touched base with EASA and the FAA, and we talked with them about hydrogen on the engine side. It was before we've been selected by Airbus on the project. So we talk with them, we explain what we are looking for, we start to explain to them what are the technical challenges, and for sure we start to talk with them about what will be the regulatory requirement to demonstrate that we can fly and fly safely, and what will be the key points in terms of certification. But for sure, for us on the engine side, it's different world. But as explained by Gael, we're coming with GE experience and Safran experience from other applications. So we have data, we have experience that we can share with them. But they are really open-minded to work with us and build this future.
And maybe just to add on that.
Right. Thank you, Michel. I'm just looking. I believe we've come to actually the end of our questions. Oh, excuse me, we have a few more. And Gael, maybe you can take this one. Can you say something about the ground test elements of this program as compared to the flight test elements?
Yeah, obviously, for any program that goes into in the air eventually, we have to test the engine on the ground. And so we will do like we do for any new development program. We will do the modifications on the Passport engine, and we will bring it to one of our test facilities and do all sorts of tests, torture that engine as much as we can, in order to make sure that it qualifies all the specifications that have been set. And it's only once it's all done positively that it will be released to Airbus, to eventually flight it on the A380. I mean, Mohammed, you want to add anything?
You answered perfectly. Thank you.
Right. Peggy Hollinger from Financial Times has asked how much we are budgeting for this program, what it will cost, and what we will need in terms of government support. Sabina, perhaps you could address that one?
Yes, I mean, as my colleague said also, it is an immense work that is needed, an investment. Anyway, it's part of our overall R&D plans, this demonstrator as well for the engine, as well for the installation on the aircraft. And we will not disclose any particular demonstrator costs. Also, whatever we can get from the governments, of course, this will help us. Now we have completely planned our R&D for the next couple of years, and it's taken a part of this.
All right, thank you, Sabina. This next question is for you, Michel. Graham Warwick from Aviation Week asks about how we will measure contrails, and specifically whether the DLR Falcon is intended to be used.
Well, Sabine may help me on this one because it will be more at the aircraft level. But definitely we will have another aircraft, okay, following the A380 to be able to capture, and the installation, as described by Sabine, is really making an isolated engine on which we will have a pure measurement about the contrails coming out of our engine. And this is used, I think, similar to the DLR. I think so. Maybe you want to add something?
I think, Michel, you perfectly said it. This is exactly how we will do it. Now, to determine which exact aircraft and which partners is still part of the ongoing work which will come.
And we'll do it in different atmospheric conditions. Just be sure to map correctly the overall envelope.
Exactly.
Okay, thank you. Sabina, let's stay with you. Andreas Spaeth has asked, will the 4 tanks fill the whole volume of the interior of the A380 main deck, or if not, how much of it is needed?
I mean, we will, as you have seen that in the little film, we will install four individual tanks in the back of the aircraft, so it will not fill the whole aircraft and not fill the whole main deck neither, so it will be in the back of the aircraft. It will be sufficient to really power the engine, test the entire system, and have a meaningful demonstration of what we want to do afterwards for real aircraft. So this is what it's going to be. It will also, and this is specific, have an hermetic sealed container around them in order to take all precautions that we would necessarily need to take.
All right, thank you, Sabina. One more for you. Mark Pilling from Flight Global has asked, at the Airbus Sustainability Summit that we had back in September 2021, Guillaume Faury indicated that we would have selected a fuel technology in 2025 and launch a zero-emission aircraft in 2027, 2028. And the question is just, does this demonstrator program we're articulating today fit in with that time frame, or have we changed our ZEROe schedule?
No, it's exactly fitting into that. We are doing step by step. Though the technology bricks in the first step, the demonstrator, the flying demonstrator, is a crucial step of it. We will do our choices of the technologies and the different configurations in the frame of by 27. And as you've seen, we want to fly this demonstrator by the end of 26. So we are exactly in that time frame in order to do the right choices for the steps forward.
All right, thank you, Sabina. Mohammed, this one is for you. It's from Bjorn Ferm at Liam News. And Bjorn wants to know if the Passport, being a lower bypass engine, is representative of a high bypass or an open fan engine when it comes to specifically contrail formation.
Oh, absolutely. I mean, this is one of the things, obviously, that we want to study. And one of the reasons we selected Passport is actually it's quite representative of what needs to happen. Scaling the effects from Passport to other engines, that we know how to do. The key thing is getting that data point about what the technologies are needed to achieve hydrogen, the changes that are needed, and we talked about them already, and how they affect the emissions and contrails after that, which is part of the overall program that we have. So we believe actually Passport is quite suited in that size and in the design, particularly in the core, which is the key thing that actually affects the whole combustion, which is happening inside that core, to be a representative data point for understanding the whole envelope after that, that will give us the insight that we can build on it for the future. And since you mentioned the open fan as well, as we said last summer, we intend everything that we do in the RISE technology demonstration program that it will be 100% safe capable, and it will also be hydrogen ready. And this program is part of the technology bricks and enabling to make the open fan and RISE to be hydrogen ready in the future.
All right, thanks, Mohammed. And that may address in part the next question, but perhaps, Gael, you might want to add something to this. Bruno Trevidic has asked, could you explain the choice of the GE Passport engine for the demonstrator as compared to using a CFM engine?
Sure. So, I mean, for the engine itself, what is important is to, again, as I said, is how to convert this liquid hydrogen into gas, then, take this combustion into the combustion chamber, modify the combustion chamber accordingly, and that the Passport is absolutely representative of anything we can dream of in this respect. The LEAP is a bigger engine and heavier engine. So we could have done a LEAP, but would have created more structural issues with the A380 and stuff like that. So what we can do with the Passport is exactly what we can do with the LEAP, except it's just a lighter engine. So it made a lot of sense to use the Passport for that respect.
All right, thank you, Gael. This next one from Flug Review is, what kind of materials could be used for the combustor as well as for the fuel pipes and the seals? Mohammed, maybe you can start that one?
We might convert this into a design review right now. It's early. But in CFM, GE, and Safran, we have a huge arsenal of technology capabilities when it comes to materials and coatings. And all of them will be considered. This is actually part of the technology maturation as part of this program, to look at all of these material capabilities that exist within our collective companies. And they range from metals to coatings to ceramics, which today, as you know, in LEAP, we have ceramic capability, as well as in GE 9X as well. And all of these material capabilities, they form a great base to build on, that we will select the best material that will suit the technology demonstration program and any future potential engines in the future.
Okay, thanks, Mohammed. Let's go back to Toulouse for this next one. So the question is about the tanks that are located within the A380. The hydrogen tanks are in a hermetically sealed container. But what sorts of safety precautions will need to be put into place around the ground test, specifically the ground testing of the engine? Can you describe some of those safety measures that will be required?
I mean, we have heard it. The engine will be ground tested in itself, first of all, in CFM, and Michel will maybe add on this, and then it will be added and integrated into the aircraft. So we will have a full set of ground tests before we are actually going onto the aircraft. So Michel, I don't know if you want to add on that.
Yeah, and all together we'll do our flight readiness review and we'll look at all the safety aspects. On our side, it's exactly the same thing as explained by Sabine. We'll start by design, calculation, simulation, then after that component test, system test, and after that the full engine test on ground in different conditions to declare its flight safety. And that's the kind of document that we will have to deliver to Sabine, and Sabine will run the same thing on the aircraft side.
So, and if we look again,
Thank you,
I
Michel.
just wanted.
yeah, if
Go ahead,
we
Sabine.
look again on the system side, we are also starting already this year ground demonstrators on, for instance, on the fuel system. How do we distribute liquid hydrogen? All these things can be done in parallel before we're actually joining them and bring the things together.
If I may add, today we are testing with hydrogen. We have been testing with hydrogen. And as I mentioned, we have 8 million hours of land-based experience with hydrogen. So we know how to put the safety precautions around that. And all of this will be taken, and these learnings will be taken into the future ground testing on this program, as well as into the flight testing that we will be performing.
Thank you, Mohammed. Sabina, we're back to you in Toulouse for these next two questions. The first is how much liquid hydrogen will actually be stored on board the aircraft? And the second is whether the test engine installation on the A380 could be used for an open fan demonstrator in the future.
Okay, thank you for the question. So first of all, coming back to the tanks, so we will have 400 kilos of liquid hydrogen on the aircraft for this demonstration. And then, of course, once we have the installation of the engine there, you all know that hydrogen can be used as well in gas turbines as well as in open fans. Will we use exactly that? Has to be determined, but I think the structural preparation for the things are probably something which is opening the scene for whatever things, and the asset is still there. So we are planning to do exactly this demonstration flights with the engine, which is a gas turbine. Whatever else we haven't determined yet.
All right, thank you, Sabina. And we'll end our Q&A there. That's all the time we have for today. But I'd like to thank you all for submitting the questions, for joining us this morning. And I also want to say a special note of thanks not only to our speakers here in Washington and there in Toulouse, but to all of the teams behind the scenes who helped make this broadcast possible. Now, this event will be available shortly for download for those who were not able to tune in to the live broadcast. And for those members of our media who are from broadcast or online news outlets, we have a video news release that's already available featuring statements from Airbus CEO Guillaume Faury and some of our speakers today, as well as the animation of the demonstrator that you saw revealed earlier in the program. And you can be sure we're going to keep you up to date on the progress of this exciting journey over the coming weeks and months. But for now, thank you very much and have a wonderful day.